Hi, I'm Syakir and I will present the introduction for our project that is food processor. The background. A food processor is a kitchen appliances that help with repetitive food preparation operations. Although some manual devices are also referred to as food processors, the term mainly always refers to an electric motor-driven appliances today. The aim? This research is to reduce products' environmental impacts during their life cycles. The need to figure out which items have the most room for improvement. The objective is to identify the food processor that could have a negative effect on the environment over the entire life cycle, from cradle to grave. Suggestion for changing potential to see whether and how the life cycle consequences of the most impactful goods can be minimized. The scope: concentrate on distinguishing goods based on their life cycle effects. Identify goods based on their total amount of the commodity that was used. Pay attention to the product that were used to make the product. And lastly, concentrate on the components and part of the food processor's production process.
Assalamualaikum. My name is Muhammad Shamil bin Shamsul BAHRIN, and I would like to share the literature review of a food processor manufacturing sustainability. The original design involved a lot of different parts that translate to high costs and environmental impacts. To improve the number of parts in a food processor, multiple parts has to be redesigned and morphed together to reduce the number of parts. By doing that, environmental sustainability implications are greatly reduced. Next, product optimization through usability testing. The food processor's inherent problem is that it sits on our counter more than it's being used. Therefore, there's an idea to create a stowaway food processor machine that can be used as a working surface concealed in a kitchen drawer. With that idea in mind, buyers are more aware of their purchase and will negate from just buying a new one as it's application specific. This solution is great for countries that have limited space like Hong Kong and Singapore.
My name is BINTI ROSMADI, and I will explain the next part, which is redesign for sustainability. In this section, I will explain the changes made to create a more sustainable food processor. It is very well aware that material will determine the manufacturing process of the product. Therefore, by changing the material, it will change the manufacturing process too. Parameters during production will greatly affect the environmental impact. In this situation, the number of parts remain the same while the components material change from ABS to PLA and HDPE to natural fiber polymer composite. In addition, we also have paid attention towards distribution phase, which is the packaging. The packaging are changed from polystyrene foam to corrugated bubble. The material component that will be changed from ABS to PLA is the control panel component. The manufacturing process of ABS has more harmful impact than PLA. This is because the melting point of PLA is between 180 degrees Celsius to 210 degrees Celsius, while the melting point for ABS is 250 degrees Celsius. The heated bed for PLA should be set to 60 degrees Celsius, while ABS has to be set at 100 degrees Celsius. Therefore, in terms of energy consumption, 3D printing with PLA filament is the most sustainable approach. It is the most suitable alternative as both materials are the cheapest choices for 3D printing. Next, movable loop, bowl cover and food chute lid material will be changed from HDPE to natural fiber polymer composite. Natural fiber polymer composites are a mixture of HDPE and paddy straw. In terms of manufacturing process, both materials go through the same processes. By reinforcing natural fillers with polymers, it contains less HDPE granules, which may reduce the production of HDPE in a year and optimize the waste of paddy straw, which most farmers burn. Therefore, by using this material, we can reduce the environmental impact of burning paddy straw and also reduce the biggest waste material, which is paddy straw. Lastly, during the transportation and distribution process, majority will choose polystyrene foam as it is lightweight and the cheapest solution. Although polystyrene is recyclable, it is not biodegradable and it may take forever to decompose. Meanwhile, corrugated bubble only takes 6 months to decompose as it is made out of completely recyclable and naturally biodegradable materials. Therefore, corrugated bubble is the best solution to decrease the environmental footprint created by thermoplastics. Based on our discussion, these are the most crucial part that needed to be changed based on the LCA method used, which my colleagues will explain further.
Assalamualaikum and hi, my name is Nikmah Masyara Amir bin SHAHIRAN. So now I'm going to talk about product lifecycle thinking for the all design. So first for the electrical parts, first we take the raw material and then transport them to the material extraction. After the material being extracted, it will be put through the fabrication process to fabricate the parts, which is box, circuit and motor. After the parts are complete, it will be sent to the assembly and packaging process. The second part is metal parts. It starts with the raw material being transported into the material extraction. After the material being extracted, it will be put through the metal processing manufacturing. This manufacturing will process 9 parts, which is shred this, grating this, French fry this, and julienne this. Center post, this stem, door blade, and multi-purpose blade. After all the parts are complete, it will be sent to the assembly and packaging process. The third part is plastic. We start with the extraction of the petroleum, and then it will be transported to the material extraction. There are 4 materials being extracted, which is high density polyethylene, also known as HDPE, polyethylene terephthalate, also known as PET. The third part material is plastic process for manufacturing, and then the fourth material is acrylonitrile butadiene styrene, also known as ABS. As for the HDPE material, it will process the food chute lid, movable loop, spatula, and the bowl cover. As for the PET, it will process food chute and bowl part. And for the plastic, it will process the food pusher, base, and slide button. And for the ABS, it will process the control panel parts. After all the parts are done, it will be sent to the assembly and packaging process. As for the packaging, we use the polystyrene foam for the packaging. So it starts with the chemical substance and it will be transported to the material extraction. After that, it will be patterned into the design shape and it will be sent for the assembly part. After the foam is complete, it will transport to the store and ready for the packaging. And now for the product lifecycle thinking is for the new design. So for the electrical parts, it's same as the old design, which is start from the raw material being transported to the material extraction, and then we will go through the fabrication process to fabricate the parts, which is box, circuit, and the motor. After it all complete, it will be sent to the assembly and packaging process. And the second part, which is metal. So for the new design, we will use the recycled metal, and it will be transported to the material extraction, and it will go through the metal processing manufacturing to process the part, which is shred this, grating this, French fry this, julienne this, center post, this stem, door blade, and the multi-purpose blade. After all the parts are done, it will be sent for the assembly and packaging process. And for the third part, which is plastics, we start with the extraction of the petroleum. It will be transported to the material extraction, and for this we use 3 types of material, which is high density polyethylene, also known as HDPE, polyethylene terephthalate, also known as PET, and the last one is plastic. So for the HDPE, we create 5 parts, which is food chute lid, movable loop, spatula, bowl cover, and control panel. For PET, we process food chute and bowl. And for the plastic, we process food pusher, base, and slide button. When all of the parts are done, it will be sent to the assembly and packaging process. As for the packaging process, we still use polystyrene foam, but we use the recycled polystyrene. So from the recycled polystyrene, it will be sent to the material extraction, and the material will be extracted, and it will be patterned into the desired shape. After that, it will be sent to the assembly pot, and after the polystyrene foam complete, it will be sent to the store by transportation to be ready for the packaging.
Web indicator for the old and new food processor designs are as follows. The older design obtained less than average for its material selection as well as optimal life. That is because the product is not designed to be sustainable for the environment. As for the new design, different materials has been chosen to achieve its sustainability KPI. The design has been greatly improved by reducing the number of parts and improving its end-of-life transition process.
We continue to the next part, which is eco indicator. Eco indicator is used to calculate the potential improvement on the environment on the food processor manufacturer and the type of material. Firstly, we create the process tree for food processor. On the left side is the old design and the right side is a new design for food processor. The improvement we make is we change the material on the old design, which is HDPE, PET and ABS, to the more sustainable material, which is natural filler polymer and PLA. The assumption product lifespan of food processor for old design is 4 years. The average of daily use is 600 watt for 50 minutes a day. The distance to be transported for distribution is 200 km. Based on the assumption, we calculate the energy use, which is 14.6 km watt per hour, and distance to be transported for distribution is 2.2 ton per kilometer. All the value of life cycle element will evaluate on eco indicator for all design, which is get the final result is 2899.637. After a redesign process to make a product more sustainable, the assumption product lifespan of food processor increased to 6 years. Average of daily use is 600 watt for a 50 minutes a day, and the distance to be transported for distribution is 200 km. And energy use is increased to 21.9 kilowatt hours, and the distance to be transported for distribution is decreased to 2 ton kilometer. The eco indicator for new design has calculated, and the value is 2818.947, which is lesser than before. The summary for eco indicator is the larger the eco indicator value, the higher the effect on the environment. After the redesign process, the value of eco indicator is decreased and the incremental effect on environment is decreased.
As a conclusion, the food processor use some of the most environmental friendly production methods, such as metal casting, in which metal are melted into forms that can be reused and recycled to create new items. Plastic has become a low-cost and suitable alternative for manufacturers. Components made of plastic took 1,000 years to decompose, and environmental impact has gotten worse due to the wait for the plastic to decompose. When creating a plastic-based product, manufacturing companies must be cautious. Manufacturers must strategize from now on to achieve sustainable development in terms of the climate, social, and economic growth. Food processor manufacturers should strive to create goods that can reduce resource use to improve manufacturing performance, eliminate unnecessary resource usage, and reduce the amount of waste and emissions generated during manufacturing activities. Thank you.